guys, I'm looking at page 236 in section 3.1. So now we're going to talk about the basics of applications and modeling. So we have actually talked about this in chapter 1, and you should have actually come up with like a whole list of words that go with mathematical modeling. So this was the list that we talked about, and so I just have this listed out here for your reference. And now we need to add on some new words to make equations. So the question here is, what words indicate an equal sign with applications or modeling? Well, the words that will indicate that we want to use an equal sign will be things like is, or are, or was, or were. Also, of course, if the word equals is used in there, or if it's something like is the same as. So those are all phrases that would kind of indicate that. So what I want to do is I want to start working on writing certain statements as equations. So we're going to start with kind of the basics here. So 15 more than a number is 19. You will notice that this translates pretty directly from that chart that we have above. 15, of course, would mean 15. More than, what operation does that mean? This part here means plus, and then the concept of a number, that's what we're trying to find, right? So we don't know what that is. That would indicate an x. Then we just talked about how the word is means equals, and then this last part, 19, will just mean 19. So what you're going to find as you look at these is that every word should actually have kind of a translation from the chart that we have up here above. So if you're kind of struggling with this, you might want to have this chart kind of next to you. So the equation that I want to solve then is 15 plus x equals 19, and then I can just solve that as usual by subtracting the 15 to get x equals 4. Okay, so what I want to do is I want to go through several examples together, and I want to point out something. So the word less than. So in this next phrase, so we have 9 less than a number is 12. So less than is one of those words that works a little bit maybe counterintuitively. And this really matters. So you know that less than means subtraction, but when you think of the phrase less than, I always think of it as less than a starting point. That's the way that I think about this. And I bring this up because this is actually kind of this is not going to work as 9 minus x, as you might think. What this means is that the starting point is this, and then you're supposed to take 9 away from that. So this can be a little bit counterintuitive. I kind of chalk this up to, if you speak another language, there are certain words that are irregular verbs or just irregular words that don't work the same in English. Well, now we're translating English to math, and this is kind of the same idea, right? So you kind of just have to learn how to interpret subtraction. So if I go through and I try to interpret this, so 9 is 9. So this is indicating subtraction, but it's going to work in a slightly different way than before. So I'm just going to indicate that that means subtraction. And it's really subtraction from is the way we want to think about that. This a number, that will stand for x. Then we have is, so is will still make the equal sign, and then of course 12 will indicate 12. So the actual way that this will present itself is x minus 9 equals 12. And so now what I want to do is I can go ahead and I can just add my 9 to each side, so I get that x equals 21. So that would be the solution to this one. So that phrase works a little bit different from the next one, which uses the word decreased by. So let's read this. 3 times a number decreased by 8 is 40. So in this case, this now will work exactly in the way that you think it should. So the starting point here is this 3 times a number, and then you decrease it by 8. So what I want you to do is I want you to take a stab at just writing this out in its proper form. So this is going to be 3 times, and then a number is going to be our x. Decreased by will mean minus, and we can just go in order, and then 8 is just 8, is here's my equals, and then we have 40. So I have kind of the whole structure on here. So the actual way that this is going to write out, this is going to be 3x minus 8 equals 40. And so then this is what I'm going to solve. So then I can add 8 to each side. I get 3x equals 48. I can divide each side by 3, and then ultimately I'll get that x equals 16. So that would be my solution to that one. Okay, so now what I want you to do is I want you to try these next couple of examples on your own. Pause the video, try to write them out, try to solve them, hit play when you feel ready. Okay, so this one is using the word less than again. So remember, that is less than a starting point. So it's, sorry, I messed that up. To less than. Okay, so the way that I want to think about this then is this is 2 less than 1/4 of a number. So I need to start with this 1/4 of a number. So the 1/4 of a number will be 1/4 x, and then I take 2 away from that. So that's what that 2 less than a number, 2 less than 1/4 of a number is 3. And the 1/4, so it's 1/4 of, so 1/4 is just going to be the fraction. Of means multiply, a number means x. Is means the equal sign, and then 3. Okay, so now I can go ahead and I can solve this. So I'll start by adding 2 to each side. Then I've got 1/4 x equals 5. And how would I get that 1/4 gone? Well, you can just multiply by the reciprocal of a fraction to get rid of it. So what I mean is I'm going to multiply this side by 4/1, which what is 4/1? 4/1 is the same as just 4. So when I do that, the 4's will cancel out, and so everything will cancel out, and I'm just left with x. So ultimately my answer is x equals 20. Okay, moving on to D. A number decreased by 9 is the same as 7 more than half the number. All right, so this actually has 2 pieces to it now. Notice that I have is the same as, so there's an equal sign right in the middle of this. So let's start with this first phrase. A number decreased by 9. So a number decreased by 9, x will be the number, and then to decrease by 9, I just subtract 9. That would be the first part. Then it says is the same as, so that's my equal sign. And now I have 7 more than half the number. Okay, so 7 more than, so that's 7 plus. And then half the number, there's different ways you can interpret this. You can call this part here, maybe I'll just highlight this, half the number, and I'll write out a couple ways you could do this. Half the number could be x divided by 2, or it could be 1/2 times x. Tomato, tomato, totally doesn't matter which way you want to think of this as. It'll still result in the same thing. Why don't I just write this as x over 2 just to show you a slightly different way to do this. So now I can go forward with this. So I'm going to subtract off, let's see, I'll subtract off the 7 here. So I now get x minus 16 equals x over 2. And now I need to subtract the x from each side. So I'm going to get a little crammed here. But so this is x over 2, or like I said, 1/2 x, tomato, tomato. And so 1/2 x minus 1x, that will give me actually negative half x. So this will equal negative 16 equals negative, I'm going to rewrite this as negative 1/2 x. So now to get rid of this, to get the x by itself, I just have to multiply by the, not just the reciprocal this time, but also the negative reciprocal so that I can turn this into just positive x. So I'm going to multiply this side by negative 2/1. So look at what happens over here. That crosses out this 1 and this 2, and it turns everything positive, so that resets everything. And then if I multiply the same thing over here, negative 2/1. So remember, negative 2/1 is the same thing as just negative 2. So I can actually just write this as negative 2. And now I get that x equals 32. That would be my solution here. All right, so let me give myself some more space here. So 7 less than 3 times a number is the same as twice a number plus 3. So let's see. Let's start with this first part. 7 less than 3 times a number. So again, it's 7 less than that starting point. The starting point is 3 times a number, so the interpretation of 3 times a number is just 3x. And then I subtract 7 from it. So there's 7 less than 3 times a number. This says is the same as, so now I have an equal sign. Twice a number plus 3. So that would be twice a number is 2x plus 3. Okay, So now I can go ahead and solve this. So I subtract off the 2x. So now I get x minus 7 equals 3. And then I add 7 to each side. So I get x equals 10. That would be my solution there. Okay, and now for this last one. 2/3 of a number increased by 1 is the same as 4 less than 1/2 of a number. Okay, so this one has a little bit more to it. So let's just start with the first part. 2/3 of a number increased by 1. So this is 2/3 of a number that's 2/3 x, 2/3 times x. Increased by 1 means plus 1, and then is the same as will be equals. Okay? 4 less than 1/2 of a number. So let's start with the 1/2 of a number. That will be 1/2 x, and then minus 4. Okay, so as it stands, we're going to have to do a little bit of work with fractions now. I know that always makes everybody so happy. So let's start by subtracting off the 1. So I get 2/3 x equals 1/2 x minus 5. And now I need to subtract off my 1/2 x. Okay, so let's blow out the detail over here. So I have 2/3 x minus 1/2 x. Well, to do this, I need to have a common denominator. What is the common denominator between these two fractions? It would be 6. So what do I have to multiply 3 by to get to 6? I would have to multiply 3 by 2, and that would turn it into a 6. So I'm going to multiply this by 2. Whatever I do to the bottom, I do to the top. So that's what I need to do to this fraction. And then what do I need to multiply 2 by to get to 6? I need to multiply 2 by 3. So I'm going to kind of run out of room here. And whatever I do to the bottom, I do to the top. Okay, so now let's multiply this together. 2 times 2 is 4. 2 times 3 is 6. So this is 4 6x. And then over here, 1 times 3 is 3, and 2 times 3 is 6. So there's what my calculation becomes. So now this is ultimately going to equal 1 over 6x. Okay. Whew, I know it's a lot of work, right? So I'm going to kind of sanction that off over there. So now what I get over here is this becomes 1 6x equals -5, and now we're in the home stretch. How do I finish this? Well, I'll multiply each side by 6 to get rid of the fractions, and I get x equals -30. Okay, great. So now, let's move on to these next two examples. So these are now more complicated looking examples of kind of what we were doing before. So let's read this first part together. A new car worth $24,000 is depreciating in value by $3,000 per year. After how many years will the car's value be $3,000? So what you have to do here is kind of unpack what operations are being assumed here. So starting with kind of, if I rephrase this problem, so it says, a new car worth $24,000 is depreciating in value by $3,000 per year. So this piece here is actually giving us a huge clue into kind of what this looks like. We have a starting point here of $24,000, and then it's depreciating. So depreciating means what operation? Depreciating means subtraction. And then this concept of $3,000 per year, this is also actually telling us an operation. This per is telling us 3,000 per year, so we don't know how many years. So this is actually telling us 3,000 times however many years we need. And then it says, after how many years will the car's value be $3,000? Well, we're wondering then, what does it mean to be $3,000? That would be, what does it mean to be, when will this car equal, it's worth equal $3,000? So the setup for this equation then, we start at $24,000 and we decrease $3,000 per year, but we don't know how many years in this case, so I'm just going to write this as 3,000y. And I want to know, when is this situation going to equal 3,000? Here's the situation. And so now we can actually solve this. So I can subtract the 24,000 from each side, and I get -3,000y equals -21,000. divide each side by negative 3,000, and I get y equals 7. So this other question says, what is the solution to this situation and what does it mean? My solution is y equals 7. What does this mean? Okay, so now let's move on to the next one. You are choosing between two health clubs. Club A offers membership for a fee of $22 plus a monthly fee of $12. Club B offers membership for a fee of $25 plus a monthly fee of $11. After how many months will the total cost of each club be the same, and what will be the total cost for each club? So I would recommend that maybe you try to model out this situation. What we're trying to figure out here is when will Club A equal Club B. So you actually need to model that part out. So that's kind of a hint for you. I would recommend pausing, hit play when you're ready. So if I wanted to model out the cost structure for Club A, it's $22 plus this monthly fee of $12 per month. So I don't know how many months that is, so that's 22 plus 12M. And then on this other side, this is 25 plus 11M. So that's $25 a month, and then $25 plus a monthly fee of $11. So here's how that would be modeled out. So now we can go ahead and solve this. So I'll go ahead and I'll subtract off the 11M. I get 22 plus M equals 25. Subtract off the 22, and I get that M equals 3. So the solution to this then is that after 3 months, the clubs cost the same, but we also need to answer in this, what will be the total cost for each club? So that's this part here, what will be the total cost for each club? So maybe I'll just do this total cost calculation. To figure that out, you need to plug in 3 into either one of these sides, right? After 3 months, they should be equal. So I will just plug this into the first one. So 22 plus 12 times 3, what does that equal? That's 22 plus 36. So ultimately, that equals 58. So I need to add that into my solution, right? After 3 months, the club costs the same amount of $58. That's the solution and also what it means. So you want to make sure that you're being nice and thorough when you answer these things. Okay, so this was a bit of a longer video, but word problems always are. So I will end it here, and then I'll see you guys in the next video. Thanks for watching.